So for section 2.5, we're going to look at geometry applications. And here's an easy one. If we have area, here's a linear equation, the area of a rectangle. They're going to give us some of these formulas, like right here, area is length times width. And then basically, they're going to want us to fill in the pieces. So they tell us the area is 64, so we're going to put that in place of the A. And they tell us the length is 10. We're going to put that in place of the L. So we have 10 times W. So if I want to solve for W, we are, once again, we're undoing. We have 10 times W, so to undo that multiplication, we use division. And then we've got a bit of an option here. See, I've got 64 over 10, and they're going to want that either as a fraction, which means I'll divide the top and bottom by 2 to get 32 over 5, or I would be okay if you put that as a decimal. 5 goes into 32 6 times, 5 goes into 24, so 6.4. Either one would be fine with me. This is more often how they're going to want it in the homework. Okay, so keep that in mind. Generally, we actually want to keep a fraction. It is the simpler form as far as operating in mathematics. Fractions are easier. Decimals is where we kind of round it off and go 6.4 makes sense. 6.4 times 10 makes 64. All right. Here's another formula. The area of a trapezoid, 1/2 the height times the little base plus the big base. So I normally call it base 1 plus base 2. So we add the bases, we multiply by the height, and then we end up with half of that. Okay? So we fill in the area, 210 equals 1/2. The height we know is 10 times base 1, we don't know, little b, plus big B, 27. We can handle this. See, I can take that 10 and I can distribute it at this point, but since it's on the outside with the half, I would actually multiply those two together first. So 210 equals half of 10 is 5. Now at this point is where I would take the 5, since there's only a single term out there, and distribute it. So 210 is equal to 5b plus 100 plus 35. How about 135? I go to subtract that away. Subtract that away. We end up with 75 is equal to 5b. And if I divide by the 5, I get that base must be 15. So, we're going to need to be able to take these formulas, plug in pieces, and solve for what's left. This is a little messier just because they don't give us a picture, but they said it's in the shape of A. So draw a rectangle. So Carrie's backyard is in the shape of a rectangle. The length is 5 less than twice the width. Okay, remember this is like we had in the previous section whenever we have these word questions. It's like I can call one L and the other one W, or look, they're comparing the length to the width. The width tells me I can call the width W, and the length is 5 less than. The length is 5 subtracted from twice the width. What does this do for me? Well, I'm just going to use the width and then this for the length so that I have one variable. And the perimeter is equal to 80. What is the perimeter? Well, that's if we were to walk all along the outside of this sucker. If I were to walk all the edges, it would add up to 80. So that's width, 2 width minus 5. How wide is this? Still W. What's the length of this? 2W minus 5. So we can add all that up. W plus 2W minus 5 plus 2W minus 5. So that would be all 4 sections of the wall, and they should add to 80. My like terms, if I add all the W's, 6W minus 5 is minus 10. If I add the 10, 6w equals 90. Dividing by the 6, the width is 15. What's the length? Well, if the width is 15, plug a 15 in here. 2 times 15 minus 5. 30 minus 5, the length is 25. So start by defining everything as one variable, then solve for that one variable, plug back in to solve for the other one. Longest side of a triangle is 3 foot longer than the shortest side. The medium side is 1 foot longer than the shortest side. Okay, let's go back. I don't have a picture. Draw a picture. What's our then? What's our thing that we're comparing everything to? The longest is 3 longer than the shortest. I'm going to call that S. The medium is 1 foot longer than the shortest. That's our S. We're comparing everything to this shortest side. In fact, the longest side is 3 longer than the shortest. So that would be just the shortest plus 3. And that's basically the longest side, right? The medium side, M, is 1 foot longer than the shortest. So that would be the shortest plus 1. If the perimeter is 16, once again, what is perimeter? All those sides added up. That really is the small plus the medium plus the large, but I don't want 3 variables. So I got the small plus the medium plus the large equals 16. Combine our like terms. 3s plus 4 equals 16. Inverse operations, we subtract first, so that 3s equals 12. Divide so that s is 4. Good, s is 4. So what's the medium? 4 plus 1. The medium must be 5. What's the large? 4 plus 3. So the large must be 7. And all 3 of those together add to 16. The area of a triangular sailboat. Now this gets a little more complicated, but nice that they give us a picture. What I don't see is the area of a triangle. So this is one that you either need to know or you're going to have to hit the help me button and look up the formulas. For the test, I will give you all the formulas you need. I would expect you to know that the area of a triangle is 1/2 base times height. Okay? If I ask you to use any of these formulas, besides like perimeter, if I ask for any of the areas, I'll give you the formula, or if I give you volume, I'll ask you for that, okay? What is the 126? Well, that is the area. Is equal to 1/2. The base we know is 12 times the height is what we're solving for, h. Well, nicely enough, I can do 1/2 of 12. So 1/2 of 12 is just 6h. Solving for h, I'm going to divide both sides by the 6 and get that the height is 21, I think it was, feet. Yeah. All right, so, I mean, that's kind of what we're going to be doing with the formulas. They're going to give you the formulas, you fill them in. Now we're going to apply it to a little bit more geometry. The good news is it's actually going to build on what you already know. A vertical angle is whenever I have 2 lines that kind of cross and make an X. What we end up is with the opposite angles are congruent. This angle here, if I had this as angle A, would be the same as the right side, B. Angle A is equal to or congruent to angle B. If I call it angle C up here, that would be the same as angle D. Vertical, I know we think of it as up and down, but to get these vertical angles, to get the congruent angles, it's either the left with the right is congruent or the top with the bottom. So angle C is congruent or equal to angle D. So that's the only new thing, but it's kind of like a, yeah, of course, they literally look the same, right? No matter what I do, these angles that are opposite each other will be congruent will be equal measures. Straight angles is if I ever have any two angles that add to make a straight line. They are not equal. They could be, but they're not always. But if they are straight angles, then we know that they add to 180 degrees. These angles are supplementary is the word. Okay, so vertical angles, the angles opposite of each other are the same. Straight angles, the angles are supplementary or add to 180. So look at this. The one on the left, what are we dealing with? Straight angles or vertical angles? Well, you're like, vertical's up and down, these are left and right. It doesn't matter. The angles that are opposite each other, when we get this X shape, are equal. So that's how I set up my equation. I set the 2x plus 24 equal to the 4x minus 40. How do we solve that? The same way we've done these algebra equations before. I've got a variable on both sides, right? I can't simplify, can't combine like terms, so I'm going to isolate the x by subtracting it over. Getting us 24 equals 2x minus 40. Now we're ready for inverse operations. We add first and get that 2x equals, how about, I'm not thinking straight, 24 plus 40, how about 64? Then to undo the multiplication, we divide and get that x is about 32. On the right, these angles are not equal. They don't even look equal, okay? But that's not what they're saying. These two angles form a straight line. Therefore, they add. If I add them, they are supplementary or 180 degrees. You should not be doing this. This is utter nonsense. What I do to one side, I do to the other. This was on the same side. We don't do that, right? When they're on the same side, we can take the like terms and combine them. So over here, they were opposite sides. We had to move them. This, they're on the same side. We combine them. Now we're ready for our inverse operations to undo the adding. What is that? 168 to undo the multiplying. So that x is equal to 21. Kind of our last little bit, we need to be able to take equations and solve for pieces. So I have to solve for a variable even if I don't have numbers. So do you see this equation right here? We are solving for t. I want that t all by itself. Well, what's happening to that t? Well, this is PRT. That means P times R times T. T is being multiplied by P and R. How would I undo that? How would I get that T by itself? How would I undo multiplication? The same way we always have. To undo multiplication, we use division. Of what? Well, what's it being multiplied by? P and R. And if I divide it by both of those on one side, I do it on the other. These cancel out, leaving us with just T is equal to I over PR. And that would be it. See, the idea is, we did this at the beginning where I plugged in numbers, but what if I was, and I'm not sure what this is one of those science formulas, but if I was using this formula all day long and kept solving for T, solving for T, solving for T, well, what I've done now is I've created a new formula so that if I know I, P, and R, I could plug it in here and get T a lot faster. So that's really the goal of this, not trying to make your life more difficult. We actually are going to be using this in the sciences. I want to know how to modify the formula to make my life easier. If this was a formula I was dealing with, and once again I was solving for T, what's happening? Well, it's being multiplied again. Sweet, divide it. Not yet. It's also being added. So remember, for inverse operations, I start on the bottom and I go up. I deal with the adding first. I deal with that adding P first. So to undo the adding, we subtract. You're like, well, what the heck? What's a minus p? They're not like terms. It's a minus p. On the right side, these zero out, leaving us with p r t. Now that t is being multiplied, that's the next thing I deal with. Since it's being multiplied by pr, we divide it by pr. And if I do it on one side, I do it to the other. Now technically, I could try to simplify this on the left side. We don't really need to. A minus p over pr is perfectly good. We got the t by itself. If you wanted to make that a over pr minus 1 over r, that would not hurt my feelings, but this is fine. Next one, we are solving for a. Where's the a? It is being added by this mess and multiplied by x. What will we do first? Start on the bottom, deal with the adding first. So our multiplying is the a. Our adding is this by. So I'm going to subtract away the by first. And if I do it to one side, do it to the other. That leaves us with a times x is equal to c minus by. And if I'm solving for a lot of people will do this. That did not solve for a, right? Focus on, I want to not make the a disappear. I want to get a equals, which means I need to figure out that that a is being multiplied by the x. So I'm going to divide both sides by the x, leaving us with a equals c minus by over x. And that is how I would leave it. A couple more examples. These are more for the sciences. The last couple are going to be basically for our linear equations. We are going to be needing this, not as much in this chapter, but soon. Solve each of these equations for y. Here, y is being multiplied. That negative is multiplying with y, if you like to think of it as a negative 1. And that 2x is being added. Deal with the adding first. To deal with adding 2x, I add the opposite, or I minus, and I do it to the other side. Now let me just say right now, if you make the right side 7 minus 2x, that does not hurt my feelings at all. If you divide by the negative 1, you get negative 7 plus 2x. I'm totally fine with that. You're going to be fine. It will come in handy if we start learning to put the x first. That will help us in later chapters. So we would have a negative 2x and a positive 7. It will not be the difference between right or wrong, but if you can start putting that variable first, it will be a good habit. And then to undo with multiplying by negative 1, divide everything by, so that y is equal to positive and negative, and that's how I would write that. Like I said, if you write that as negative 7 plus 2x, it does not hurt my feelings, but the top one will be better in the long run. On this one, y is being multiplied by 2. It's being added by a negative 3. Really, it's being subtracted by 3, right? How do I move that 3x? Well, to undo subtracting, we use addition. Here's a common mistake. Most people will make that 2y. What makes me sad is people will make that 9 of something. 6 plus 3x is not 9 of anything. Those are not like terms. The 6 is a constant, 3x is an x. You're like, well, I can't combine like terms. Awesome. Then don't combine them. Leave them separated. Our last step, to undo the multiplying, we're going to divide everything by the 2. By the way, if you just make it all divided by 2 and you wrote 3x plus 6 over 2, that will not hurt my feelings. If you know to divide that 2 into each term and you write it as 3x over 2 plus 3, that will actually be better in the long run. Okay? I'm going to encourage you. We have just 2 more examples. These are the last 2. This is an A basket issue, these last 4. That's why I'm doing so many of them. If you're like, I got this, then pause it for a second, do the last 2, solve for y, and see what you get. And then you can fast forward it and compare. All right, this one, solve for y. Somebody's like, really, that's it? Because how do I move that 5x? How do I deal with that adding? Both sides, and I encourage you to put the x first. And literally we are there in one step. There was literally only one thing happening to y this time. It was just being added by 5x. So to undo that adding, we subtracted and we're done. The last example, there are two things happening to y. It's being multiplied and subtracted by x. What do I do first? Multiplying or subtracting? Inverse operations, deal with the subtracting first. To undo minus x, we add x. That leaves us with, I'm going to put the x first. If you divide everything by -2 and you write that as your answer, that will not bother me. What's a better habit is to take each term and divide each of them by the -2. So that now I have a positive y is equal to negative x, or x divided by -2, or 1x over -2. I would just write that as negative 1/2 x, or negative x over 2. And 8 divided by -2 would be, I was going to put plus -4, wouldn't bother me. I know some of you were going to do that. Or just -4. Either one's fine. So those are really kind of an A basket. That's not something that's vital now, but my goodness, we're building those skills that are going to be vital in the future chapters, because we're going to be doing this to death. So that was actually a lot of examples I went through pretty quickly. Hopefully, I remind you, feel free to pause if I'm going through this too fast. Take your time, pace yourself, make sure you understand what we're doing. Feel free to ask me any questions. See me during our class time, see me during my office hours, see me during the LRC. Make sure you understand this. We're getting close to that test. Keep up the good work.